Hello friends, welcome to our YouTube channel Tech Experts. In this video, I am going to cover a lot of concepts like static IP, public IP, TCP, UDP, LAN, WAN, port forwarding, why we need them, practical demonstration, and many more things. Practical demonstration will be at the end. So in this video, you are going to learn a lot of things, and I will try my best to teach you the best topics, best points, and shortest point possible. So this video will be little bit longer than my usual videos because I am going to cover a lot of things in this video, and I had to take too much retakes in this video because my English is not very good, but I am recording this video in English so that many people who don't know Hindi can even watch this and understand this video and utilize its benefit. So, and I also need a suggestion from you guys that if you want my videos in English only, then you can comment down below. But if you want me to make videos in Hindi only, then also do comment. If you think that I am saying this to increase my comments, then you can send your suggestions on Instagram, Twitter, Instagram, Telegram, anywhere you want. So you can comment also, you can send there also. I don't like, it doesn't matter for me. So the main thing is that I want your suggestions, your opinions regarding that should I continue my videos in English only or should I make them in Hindi. But this video is definitely going to be in English because many people find this thing hard. So I want everyone to find this video helpful, and I will try to cover a lot of concepts in this video. And also as I told that I had to take a lot of retakes in this video because even I'm recording this intro at last because I did many mistakes, many grammatical mistakes. So I hope you will cooperate with that, and if you really find this video helpful at the end, do like it because I really had to take a lot of retakes in this video because it gave me a lot of pain because after every line I said a wrong word, so I need to stop that video and start it from the scratch again. And I did this so that I can even get a more confidence also. So I hope if you guys find it helpful, then do like it, subscribe my channel if not done yet, and remember to press that bell icon because YouTube doesn't send notification if you won't select that notification bell. So I hope you guys will like this video, and let's start the video without wasting any time. Okay, so this is a summary about what we are going to cover today. So the first topic is LAN versus WAN. So imagine you have a router and 5 devices, and all those 5 devices are connected to your router through Wi-Fi. So your devices and the router has a network, and that network is a local area network, that is LAN. And if you are connected to internet, then that network is a wide area network, and you can say that your router is connected to WAN. So let's move to the second topic, that is TCP versus UDP. So these are the two basic protocols, and the TCP is connection oriented protocol, whereas UDP is connection less protocol. So what it means is TCP protocol aims to deliver all the packets and checks if all the packets has been successfully delivered, whereas UDP doesn't care about them. What UDP does that it sends all the packets, but it doesn't checks whether they are received or not. It doesn't matter to UDP. That's why UDP is little bit faster than TCP. This was the basic difference between TCP versus UDP. And HTTP is a TCP based protocol. So let's move to the second topic, that is public and private IP address. So many people say that each device has 2 IP addresses, but this is not actually true. Let me tell you the difference between public and private IP addresses. Imagine if you have a router and 5 devices connected to your router via Wi-Fi. So all your 5 devices connected to your router will have one private IP addresses, and each private IP address will be different in the same network. Means if your router has 5 devices A, B, C, D and E, then all your devices A, B, C, D and E will have different private IP addresses, but they won't have any public IP addresses. Why? Because when you purchase a router and you put a connection inside it, then the public IP will be assigned to your router, not to your devices connected to the router. So your router has 2 IP addresses, one private IP address and one public IP address. That public IP address is visible to internet, but that private IP address that one router has and rest 5 devices has, that will be accessible and visible only inside that network. What I mean to say is, if we have 2 networks, remember, not 2 devices, if we have 2 network A and network B, then if we have 5 devices connected to each networks, then device A in the network first may have the same IP address as device A in network B, because those 2 networks are totally separate. But inside a network, inside network A, 2 devices can't have the same IP address. Okay, so this was the scope of private IP address. And talking about public IP address, the router has both one private through which it communicates to the devices connected to it, and one private public IP address that is connected to internet. So this was the concept of public and private IP address. Now let's talk about dynamic and static IP address. When we use a router or anything like SIM card or internet from dongle, then we have a dynamic IP. Means every time or after some time it gets changed automatically. It doesn't remain constant. But if we pay for a static IP address, or like we are in a company or we have a server, then we have a static IP. Static means just fixed, nothing else. So our address is fixed in the case of static IP address, but if we have normal router, normal SIM card or something like that, then we will definitely have dynamic IP address. So this was the difference between dynamic and static IP address. Let's talk about bind and reverse shell and why we need them. So you must have heard about the word reverse shell, but may not have heard about bind shell. So like imagine we have two devices, A and B, or we can say we have a target and we have a victim, two devices, and the target wants to hack victim. So he has two options. First option he has is that he sends a payload. I will talk about payload later. Imagine he sends a virus to the victim. Okay, so the victim has the virus, and when the victim runs that virus, what that virus will do is that will start a listener, like it will start listening for the incoming connections. Okay, and then what our target will do, what our attacker will do, it will send a connection to the IP address of the victim. So if I say in short, then in bind shell we are sending the attacker is sending the connection to the target. Okay, why we are doing this? Because we know the IP address of the target, and the IP address of the target should remain constant. It should not change, because if it will change, then we will come in problem. And as I already talked about dynamic and static IP address, you must be thinking if that every router or every SIM card's IP gets changed automatically after some time. So how will that bind shell concept work? So it won't. That's why it wasn't so successful, because IP addresses keeps on changing. So we came with the concept of reverse shell. What does reverse shell do? So this time what we will do is we will send a virus to the client, or you can say the target, and then we will start a listener on our own attacker machine, and then the IP address and the port of our attacker machine will be already combined in that virus that we send to the target. Now when the target runs that executable or that virus, then his computer will connect to us. So what will we get, like what is the benefit of using reverse shell? The benefit is that we can't have the target to use static IP, because it's his choice, and he must be using a router or SIM card that doesn't have a static IP. But anyhow, we will manage to get a static IP so that our IP doesn't changes, and whenever the attacker runs the virus, it successfully gets connected to us. And also it will help us in bypassing the firewall, because any connection made from the target machine will be more trusted than any connection coming to the target. So this will even help in bypassing the firewalls, the system firewall. So let's talk about how that works. So that works with the same concept, but you won't see any active RAT that uses the concept of bind shell, because bind shell is an unsuccessful attempt. So everyone uses the concept of reverse shell mostly. That's a different scenario. If your victim already has a static IP, then you don't need to use the reverse shell concept. You must use the reverse shell concept in the normal scenarios. Okay, so this is how that works. It uses reverse shell concepts, nothing else. What we do is while creating the payload, we write our IP and our port to which it should send the connection, and then the payload is created, and then we send the payload to target, and when the target executes that payload, that connection comes to us. So let's talk about port forwarding concept and why we need the concept of port forwarding. So this is the most important thing, and I think this is the most important topic of this whole video, because for this concept to work out of the network, you should know this. So like we take an example of 5 devices connected to a router. Okay, so as I already said, then that all those 5 devices connected to a router will only have private IP address. So now you will ask how that devices will connect to internet. Like if they don't have a public IP address, they are not visible on internet, then how would they communicate to the websites like Google, Facebook, and how will they access internet? So the answer is that your router has 2 IP address, one public, one private, and your device B, just an example, your device B has a private IP. So when it needs to access, like example google.com, so when you open google.com in your device B, it will send a request to the router, and router will be considered as a default gateway for all the connected devices. So it will send a request that I need google.com to the router, not to the Google server. It will send it to the router. So now what will happen is that request will be forwarded to the google.com by your router. So what you do is that you open google.com, your device B sends that request, or you can say forwards that request to your router, and your router forwards it to the internet. So when the response comes, how will your router know that this response should be sent to which device? Because when you send the request, you send it to router, but you only have one gateway. Network B only has one router, but router has many devices. Then how will it know that to which device it should be sent? So this happens by you can say NAT table. So what happens there is, like, when you send a request, and when the response comes, it notes down that this was sent by this device, and therefore any response coming from this should be sent back to this device. This is how your thing works. So if you are like trying to access google.com, this is your whole path how you will get the response of google.com. So you aren't directly connected to the internet, but your router will act as a gateway, and it will serve you all the requests and responses. So this is how the normal thing works. Now talking about port forwarding, let us assume a scenario when you don't want to access anything that is on the internet, but anything on the internet wants to access you. What I'm saying is, let us assume that you have a HTTP server running on your device B. Okay, so you have a HTTP server running on your device B, and all the 4 other devices connected to your network can access it without going to the internet, because they are inside the same network, and they can access you without that so-called internet tax. So they can access you offline, okay, because they are connected to the same network. So what if anyone outside that network wants to access the HTTP server of yours? See, you can access outside, because when you will send a request, it will be like noted in the NAT table, your IP, destination IP, source port, and everything. So when the response comes, it will be distributed to you. But when anything outside the network wants to contact you, how will it know that what is your private IP or something like that? And even it can't access your IP directly. So what it will do is, you must already enable something called port forwarding. Like if your router support, we are talking about router. So if your router supports port forwarding, then what you will do is, you will manually go to the router's admin page or router setting page, and there you will put that entry. Like what entry you will put? You will put an entry that any request sent to the public IP of your router, any request for a specific port. Like if anyone tries to connect to the public IP of your router and like port 4444 to your router, then it should be sent or forwarded to this IP, like private IP, device B, and this port. So you can manually write a rule there that if anyone tries to connect the public IP of router with port 4444, then send all that request to my device, device B. Okay, don't send it to any other device like A, B, or D. Send it to device B and at this specific port. So now if I will try to access, or anyone tries to access that HTTP server inside that network where I'm not connected, I'm trying to access it via internet, then I'm on the internet and I'm trying to access that. So what I will do is, when I will send the request to public IP address of the router and like specific port 4444, then it will check its table entries, and it will see that you have already told the router to forward any packet or any request coming to this port to device B. So it will send it to device B, and I will get the response from there. So this is how I can connect to any devices inside any network. This is the concept of port forwarding, and I think you should have got an idea of why we need port forwarding. So if you haven't, then let me tell you that we are using the concept of reverse shell. So what we need is, we are not connecting to the target or the client, but our target is connecting to us, and our target is on the internet, not in the same network. If your target is inside your network, like if you and your target are connected to the same network, same Wi-Fi, same router, same Ethernet or something like that, then you don't need this concept of port forwarding, because you can directly access them inside your network. But I don't think so anybody's target would be connected to the same network. So if your target is connected to the internet, then he needs to access you, because the connection is made from your attacker to you. You are listening for incoming connections in the reverse shell concept, and your target is connecting back to you. So what you want is, your target should be able to access you. So here is the need of port forwarding. Now many router doesn't support port forwarding. So what we can do for them? We will talk about that also, and that will be covered in the practical demonstration section. So this was the need of port forwarding and why we need this. We can use port forwarding for anything like client server message application, for our websites, hosting our websites locally and then making it available to the internet, or for the concept of like rats, remote access trojans, and we can do much more things with this. So the basic idea is that if anybody on the internet wants to access any device inside our network, then the need of port forwarding is there. So I hope you have got an idea of why we need port forwarding. Let's move on to the practical demonstration now, the final and fun part. So basically I have to tell one more thing about this, then that if we can use a domain name also instead of IP addresses. For example, if I do localhost in my PC, then it will point towards 127.0.0.1, means my device only. So this is a domain name and this is the IP that it matches to. Like if we do www.google.com, our browser doesn't know what to do with this, so it sends this data to the DNS and asks for the IP. And if we do a ping, I can show you. Wait. If I do a ping on google.com, we will get the IP address. See, it is IPv6, I think so. So we won't see this. We should get an IPv4. Wait, let me show you on any other site. And now you can see that we got an IP address. This is the IP address of our server. So this is, in this address we can reach tech experts if this is the only site hosted here. So let us keep that topic aside. What I wanted to say is that at last we can communicate via IP only, not via domain. What does domain do is that it points towards our IP. So even if we put this domain or something like that anywhere, then it will point towards our IP only. So keep this in mind, and in some seconds I will show you the practical of why we need domain. So later we used to like use a concept of a domain name system. Like I don't remember its name. It was I think so DuckDNS, that people used to get a static domain name that will match to our IP every time it changes. Means we should install a software in our PC, and then that software will run 24/7 in our PC. And then every time when our IP gets changed, the domain name won't change, because like I can set this localhost to any IP address I want. Like I can set it to 117.something.something, or I can again change it to 127. That depends upon me. So that software will automatically do this. Like every time I get a different IP, it will auto match that with domain, and domain will be fixed. So we can put that domain directly into our payload. So if we put that domain into our payload, then even if our IP gets changed 100 times, then also that domain will point to the current IP. So it won't disturb our work, because we can't like embed different IP every time in our payload, because once we send our payload, we can't edit that IP again. So we need something constant inside our payload that never gets changed. So the domain name will never get changed. The IP behind that may get changed, but the domain name won't get changed. So in this way we can have like you can say that we can have a static domain name that points to our dynamic IP every time our IP gets changed. So let's see the practical demonstration first. So I will show you first on port map. We can use a site called portmap.io for this work. First go ahead in the site and register account here. Then go to OpenVPN and download it. OpenVPN. I have already downloaded and installed it. So you can simply download it and install it via this 64-bit or 32-bit, whatever your system supports. So download this software, then download this. And I am also going to use a software called XAMPP, that is a HTTP server. You don't need this, but for the sake of demonstration, I will be using this to show that our website is available out of the network also. So if you want to do this along with me, then you can download it, as you can skip this step. So what you need is port map and OpenVPN. So what will they do? Let me show you by logging in first. Okay, so we are in the portmap.io website and we are logged in now. So first let's go to configurations and select create new configuration. Name it anything. Let me name it test. Select OpenVPN here, type. Select protocol as TCP because we need a connection oriented protocol that cares about whether our data is delivered or not. Okay, we don't need that UDP protocol here. You can put any comment here, then select generate. Then select download. Here we have downloaded the OpenVPN configuration file. Why we need it, I will tell you in little bit time. Let's go to mapping rules now. Create a new rule. So what it will do here is, it has selected a host name randomly that you can't change. This host name is something like this, and with a domain, you can select portmap.io or portmap.host. I will go ahead with portmap.io only. So this is the host name. Then this is the port on portmap.io. It will be selected by random. You can't change it. You need to enter a port on your PC. What you want here is, like, you need any request sent to this address. This address is accessible by internet. Any request sent to this address should be forwarded to your PC. Okay, but on which port? I need all the requests to my port. I think so I should do it on port 4444 maybe. No, I will do it on 8080 first. So I need everything on my port 8080. Rest I don't need to touch anything. I will click on create. So this is the rule. Now what this rule says, that it is a TCP connection first and HTTP is a TCP base. So like we can use it for a HTTP also. What it will do is that any request sent to this IP and this port, this is a socket address. IP port combination is known as socket. So any request sent to this address will be transferred to 8080. But to what 8080? There is no IP defined. So it will be sent to my computer's IP address. How it will know what is my computer's IP address? For that only we have downloaded this OpenVPN configuration file. What it will do is that it will match this, like when we will use OpenVPN and install this configuration inside that, import this configuration inside that, it will know that it will actively match our current private IP with this location. So anything sent to this will be forwarded to our computer's IP on the port 8080. Let me show you this live example. First, let us open XAMPP, that is an HTTP server. I will start it. So now if I go to a URL and write this, go to a browser and write this, and after a colon you put the port. So if I do enter, maybe I should do it on port 80. Okay, so this is not a phishing page. Let me tell you this because YouTube may take it down. So I'm telling that it's not a phishing page. It's a normal page. So my HTTP server is running locally on my system, not on the internet. So I am accessing it via 127.0.0.1. That is my computer's loopback address. It can't be accessed from outside the network. Okay, on the port 80. So now if I go to port map here only and change it first to 80 because I want anything to my port 80 and update it. So now any request sent to this will be redirected to my computer's 80. But for that, first I need to do OpenVPN setup. So what I will do is I will install and open OpenVPN. If you tap that, then you won't get a screen of OpenVPN. You must go here, then you must find OpenVPN. It is here. Then do this, and you must do import first. I have already imported another file. That's why connect option is here. So go to import, select import file, select the file configuration file you downloaded. Now it is selected. Now again go here and press connect. So my file is this one. Select connect. It will start connecting. And you can see it is connected now. It has a green thing now and it has a tick. So it is connected now. So what it will do is it will actively match my IP with my private IP with this address, this public address. This is publicly accessible. This is this is port maps server, and any request sent to this server with this port number, with this port, will be redirected to my computers because that OpenVPN is actively running, and it will be sent to my computer's port 80. Okay, so now if I try to access this URL from my browser, what do you think what will happen? Yes, it will open my computer's port. It will send a get request to my, because we are using browser, so it will basically send a get request, HTTP get request. So what it will do is it will communicate with that request will be forwarded to my computer's port 80, and it will be passed to XAMPP server, and it will respond accordingly. So let us open this site, and you can see the same thing got opened here, which I opened from my loopback address, that is my computer's address. That same thing got opened here, and if this time I try to access this URL from anywhere in the world, then that will be easily accessible, noting that our firewall should be disabled. Let me show you how to do that. You can go here, Windows Defender Firewall with advanced security, or here something, maybe here also. Let us open first. You can go to firewall and network protection and disable everything here. You can see that everything, domain network, private network, public network, or firewall is disabled because it won't allow any connection. So first disable that, then only you can do this. So now it is working. So what we saw is we can use this URL anywhere, and it will remain constant. Like even if I reboot this PC, if I close the OpenVPN, what maximum will happen is that the time when my OpenVPN is not running in my PC, or my PC is not running, at that time this URL won't work, because if I disable this, see, if I disconnect this, what will happen? And now if I try to refresh it, it won't get any response, because it will not be able to communicate with my computer. So it will say something like your connection was interrupted, or host unreachable, something like that. So what maximum will happen is that our connection won't be made at this time. But if we again connect it, then we can access this page again with the same URL. My URL is not changed this time. So this was the main issue with the static and dynamic IP, that now we have a static address. This address won't change unless I delete it manually from here. So now we can put this in our payload, we can embed this in our payload and make our payload send the request to this URL, which will later be forwarded by port map to our computer's port 80, or we can define any port here. So now let me show you a demonstration of something else. Okay, so we are going to see a small demonstration of how this concept works with a combination of portmap.io website and OpenVPN. So first let me show you this two things. I have two files, client.py and server.py. So first let me show you that the client.py will be connecting to our server. Okay, this is like the reversal concept only. So like we have this IP, our loopback address 127.0.0.1 and 9999 port in our client, that I want to connect to this address, and our server also listens to this address only. Okay, our server is listening to this address and this port, and our client is sending the request to this thing. So now let us check this by running it. So I have executed the client file, and now I will execute the server file. Okay, see, you can see that we got a victim connected. Let me list the targets and let me show you that we actually got it. So now if I do who am I, you can see that we can execute any command. Now let me close these things and let me close the client as well. Now what I'm going to do is I will implement this address inside our client. Our client is basically our payload. Let me copy this. Go here. In this client I will put this address, and in the port I will put this address, this thing actually. I should not say it address. I will paste it here. So what our client will do now is that it will send the request to this IP, this domain, which maps to our IP and this port, and this is port map server, and later it will be forwarded to our IP, this IP, sorry, not this one. I have written wrong IP here. I should actually remove it. So when we use this thing, OpenVPN, it creates a tunnel named Turn0. Let us see if it created actually. This is the adapter OpenVPN. This one. So the our IP is this. Let me copy it. Yeah. So this is our IP of OpenVPN, private IP. So we will paste this IP in the listener. So we will listen at this address. Okay. And the port will be, to which port we actually transfer 80. So our port will be 80. So this is the private IP of our system, not the Wi-Fi interface. It is the IP of the Turn0 interface or the OpenVPN interface. So this is our private IP address, and this is our port that is 80. We are listening on this connection. We are listening for connections on this address, and our client will send the connection on this address, which is accessible publicly. So anyone on the internet can access this. So let us save these two things first. Let me save both this script. Okay, now these things are saved. Now let me show you the demonstration. I have executed the server. It is listening on this IP and port 80. You can see it. Now we will run the client, and you will see that we will get the connection back. Yeah, you can see we got our target connected with this IP. You can see that this IP is actually of our system only, because we connected from our system to our system only. Okay, but through the internet. Now if we do targets, we can see all the target list. And if I do target 0 and do who am I can see you can see that the response was a little bit delayed. This happened because the request went through the internet via this address and later on forwarded to our address. So that's why the speed was little bit slower, but it actually worked. So I can now send this client to anyone on the internet, and this will actually work in the same way like it did now. I can execute any command here. So this was the whole concept and the scenario of how port map works, how OpenVPN works, why we need them, why we need the concept of port forwarding, and rest everything that we covered in this video. I hope you liked this video, you enjoyed this video, and it actually took a lot of time, a lot of retakes for me to record this video in English, because it's not my habit to speak English. So I hope you guys liked it, and if yes, then I request you to like this video, subscribe our channel if not done yet, and press the bell icon for sure to get latest notifications of our videos. Thank you so much for watching this video till end, and also do comment the suggestion of should I continue this video in English, sorry, not this video, other videos in English, or I should come back to Hindi again. Thanks for watching.